To determine the value of this limit, we need to consider what happens as x approaches pi from the left and from the right, given our function. So as x is approaching pi from the left, the cosecant of x is approaching positive infinity. 1 plus the cotangent of x is approaching negative infinity. So from the left at least, we have an indeterminate form and one which would allow us to use L'Hopital's rule. Now as x is approaching pi from the right, we have to perform the same analysis. From the right, the numerator cosecant of x is approaching negative infinity, and the denominator, 1 plus cotangent of x, is approaching positive infinity. So again, we have infinity over infinity. It's an indefinite form, and it too allows us to use L'Hopital's rule. So L'Hopital's rule tells us, now that we've confirmed we can use it, that there's going to be an equivalent limit that we can find by taking the derivative of the numerator and placing that over the derivative of the denominator. So if we take the derivative of our numerator and the derivative of our denominator, we can apply that to a new limit, and that's going to give us negative cosecant x cotangent x over 0 minus cosecant squared x. Now we can rewrite everything in terms of sine and cosine so that we can simplify it a little. This will be negative 1 over sine x for the negative cosecant x times cosine of x over sine of x for the cotangent x. And then that's all going to be over 1 over negative sine squared of x. Now we can combine our two fractions in the numerator, and that will give us a negative cosine of x over sine squared of x, and that will all be over 1 over negative sine squared of x. And now we can rewrite this again by remembering that dividing is the same thing as multiplying by the reciprocal. That'll give us negative cosine of x over sine squared of x multiplied by negative sine squared x over 1. This will allow us to cancel the sine squared x's, which will leave us with simply a positive cosine of x. And if we directly substitute in pi, we'll end up with the cosine of pi, which will give us our answer, which is that our limit is equal to -1.